So today is a programming lecture, so don't open up Scratch, open up Python, open up idle. Reinstall it if you have to. But that's where we're going to be today. So idle, and I need to make a new folder for today. When I save all this stuff, I'll deal with that later. But today is another programming lecture. I am excited. This is a very, very fun piece of Python, I think. I'm going to teach you how to draw stuff in Python. That's about as close as we can get to Scratch-like stuff. And so I'm going to teach you a library called the Turtle Library. It's very cute. So let's talk about it. But before we get there, I would like to give you just another example that gets input from the user with the input function and then also converts numbers by using the type as the function. Okay, so let's go back to all this and remember it. Let's ask the user for two numbers and then compute the first number to the power of the second number. So let's say the user types, I don't know, 2 and 3. We'll get two numbers. We'll call them num1 and num2 or something. And the user can type whatever they want, and we'll put them in these variables. Let's pretend they type 2 and 3. Our job would be to compute the first number to the power of the second number. So we'd end up doing 2 to the third, right? Giving back or printing out 2 to the third, so that would be 8, right? Depending on the numbers that the user typed, okay? So let's make that happen. Just in general, this might be boring for you. Like, you know how to do this in Scratch very easily, right? Our programs have to be a bit simpler right now because we have to learn Python. We have to learn how to speak Python, and so we'll get to the fanciness that we were doing in Scratch soon, I promise. But we're just going to have straight line code for a little while that just does one thing and then another thing, okay? In general, it's going to take more code to write a Python program compared to the equivalent Scratch program. Scratch was really nice to us. Python is called a lower level language in that sense. It's really a high level language, but as far as Scratch is concerned, it's definitely lower than Scratch, closer to the computer, closer to the CPU. So yeah, let's get some numbers from the user. Remember that when we say input, whenever we say input blah blah blah, I could spell input. Third time's the charm. You give a little prompt, blah blah blah, colon, space maybe. This is going to give you back a stir, right? This will give you back a stir. And so if you want to, maybe it'll give you back the number 42 in quotes, right? It'll give you the string 42. If you want to make an int out of a stir, you got to say int, wrap it around that thing, okay? That converts from the type stir to the type int. All right, so this should come back to us with this example, I would say. So let me make a new file, and I'll save it in a brand new folder for today. On my desktop, F22 code from class, CSCI 1. I believe we are in lecture 14. We must be, right? Whee. There we go. I'll call this POW, POW for power. We're going to do the power computation, right? So we're going to get two numbers from the user. Let's say input, enter the first num colon space. I'll use double quotes for this prompt because why not? And then, remember, we're going to get back the answer from the user. We better save that somewhere, like num1. But remember first that what we ever get back from the user is going to be a string. Whatever input gives back is a string. So get the first number from the user as an int. Okay? So this will be a stir. It'll be like the string 42. It'll be like this. We can't like take that to the power of another thing. No. This can't be a stir. This needs to be an int. So we'll say int of that thing, and that'll make it a number that we can do number stuff with. So I'll just wrap this around with an int call, right? Why not? I'll say input that this part makes a string, makes a stir, and then if I wrap that in int, it'll take the stir and make it an int. Does that make enough sense? It's a weird little concept, but you can do it all in one line like this. So that gets the first number, and we'll do the same for the second number. Num2. The second number from the user as an int. And so after these two lines have completed, I have two variables, num1 and num2, holding whatever the user typed. Maybe it was 2 and 3, for all I know. Could have been anything. And then we want to calculate that answer. So calculate the first, calculate num1 to the power of num2 and print the result. Okay, so I'll be like print, and I'll use single quotes for this string because Python doesn't care. As long as I'm consistent, the result is, and then num1, the power operator is 2 stars in Python. Num1 star star num2. Okay, and that should end that print call, and we're off to the races. Look at that. That's a 3-line program, and it will do what we like. So run module. A program in Python is called a module, or a file at least is called a module in Python. Enter the first number, 2, enter. Enter the second number, 3, hit enter. And the result is 8. Yes, it is. Cool. Run module. I don't know. Enter the first number, 2. 42. Enter the second number, 42. That's a very large number as the result, but it computes it. 42 to the 42th power, 42nd power. So yeah, it takes any two numbers, num1 and num2, makes a box for them. That's how I make variables, sets them to ints, not strs, but ints, and then prints out the result we care about. Any questions about that? Just a reminder of last time. So we had to use our conversion because that gave back a str. If I wanted it to be an int, I better do input. Prompt thingy. Wrap that in an int, one way or another, and then store that in 1 or something. Okay? So that's that. Are we good with that example? Just a reminder of what we did last time. Because now I have something new for us. I'd like to teach you the turtle library. You can click here, you can search Google for it, but it is a library with pre-made code, Python turtle. A bunch of pre-made code that we can use to draw stuff. So here's like a program that you could make in the turtle library, and it would draw this really cool picture. Very colorful. So that was this program apparently. But we're going to import the turtle library, just like we imported the math library last time, and do a bunch of turtle-y stuff. Let me explain the metaphor though first. So here we go. So here's the idea. There is a turtle. Turtles are green. But somehow we got a turtle in our program. I'm not sure how we got there. But here he is with his tail and his legs. Very long legs for a turtle, I think. But there's a turtle. That's my best drawing of a turtle. Needs a better shell, maybe. And the turtle somehow got his tail dipped in ink. Okay? Maybe there was just some ink lying out or something. But the turtle got his tail dipped in ink. And so maybe he has some blue ink on his tail right now. And the turtle can respond to English commands. So the turtle can go forward and leave a mark with his tail. He can pick up his tail as he moves. He can set it back down. So you can make dotted lines if you'd like. And you can tell him to like go left, go up, go down, turn right, all those things. And hey turtle, walk. Okay, so you can command this turtle and have him draw things for you. Okay? You can also tell him to put his tail up and down, so down makes the marks, while up does not make the marks. But yeah, that's how we'll use the turtle library. Let me show this to you. It's very fun. So yeah, I'm going to import the turtle library, and I'm going to draw a square for you. Okay? Let's see here. Let's see, what's the simplest thing that I can do? I'll make a new program. I think I'll just call it square.py. There we go, and I'll import the turtle library. And then there's a million things in the turtle library that I could do. I could have the turtle move and do cool stuff. All these things are options. But remember, it's always the name of the library dot this, like it was math dot square root, it's going to be turtle dot forward, turtle dot left, okay, all those things. So there's going to be a ton of dots that we're going to use today, and I just want you to think of those dots in Python as like an apostrophe S. It's the turtle's forward function. It's the math library's square root function. Think of it as apostrophe S, and that should make a bit more sense. Like the library functions belong to the turtle, in a sense. So probably the simplest thing you could do is ask the turtle for where he is. There's a concept of a coordinate system in turtle graphics, just like there was in Scratch. So you can say turtle.position, and that will give back the coordinates where the turtle is right now. So where is that? So you can say turtle.position or turtle.pause for short. Those are the same thing. Doesn't matter. Turtle.pause will give back XY coordinate pair of where he is right now. So let me print that out. So import turtle and then be like print turtle.position. Save. When I run it, not only is it going to print the position of the turtle, 0, 0, to the text output screen, but it also makes a new window. Hoo-hoo. And this is where we can have the turtle draw stuff for us. So the turtle right now is an arrow, which is kind of ugly. We'll change that in just a second. But yeah, this is the starting of it all. I can ask the turtle to move forward, and you can see by the arrow's direction that the turtle starts out at 0, 0 facing to the right, which let's call that east. Okay, so north, south, east, west, all that stuff. So the turtle begins his life in our program at 0, 0 facing east. Okay, starts out in the middle, pointing east. So we can ask for his position. We can do so many things. Let's make the turtle look like a turtle, because what's the fun of using the turtle library when the turtle looks like an arrow? That's silly. So let me change the shape of the turtle. I can say turtle.shape and give an argument that is a string called turtle. You can make the turtle an arrow, a turtle, a circle, a square, a triangle, or classic, whatever that means. So I'll say turtle.shape turtle, and that makes the turtle turn into a turtle. So, I don't know. Make the turtle actually look like a turtle. Turtle.shape. And then, as a string, you give what you want. Turtle. Okay, that's just how the library wants it. So now, starts at 0, 0 facing east, but now he's a turtle. Look at him. We can ask him to move forward. Move forward, do stuff. Set his speed. So if I ask him to move forward by an amount, I'll show you that. Let's go back here. I think that's the first thing I want to show you, honestly. Let's do turtle speed last. There. Of course, it's unhappy about all these things that are not real words. That's okay. So I can say turtle.forward to have the turtle move in his current direction. So let me go to that documentation thing. Where's that? Move and draw. So I could say turtle.forward or turtle.fd for short. Those are equivalent. I'll just spell it out. But you say turtle.forward, and then as the argument, you give how many units you want him to go forward. That's a distance. So let's say turtle.forward by 100. Let's go back to my program. You say turtle.forward, and then you give an amount. So this is saying, Mr. Turtle, please move in your current direction by 100 units. Whatever those units may be. Maybe they're pixels, I'm not sure. And so look at him. He also begins his life with his tail down. So forward just makes him start making marks. His default color is black. So he just drew a black line right there. Isn't that cool? If I print his position now, it's going to be exactly what you think, because he started at 0, 0, right? Started at 0, 0. Now he's at 100, 0, because he went right by 100 units. So now his x-coordinate is 100. That makes a lot of sense, right? So yeah, there is a coordinate system involved. Like here's the window itself, and then here's the turtle as an arrow. He starts out at 0, 0, and then he's facing east. So he started here, 0, 0, facing east, and we just drew this line. 100. We would now like to draw this line, right? We'd like him to get up here and get to, like, I don't know, and this was 100, 0. Let's go to 100, 100. So he's facing this way. If we make him go forward some more, he's going this way, right? You go off this line. We want him to turn to the left by 90 degrees. Yes? And then he could go forward 100 more and make the right side of that square. So there's a turtle dot left and a turtle dot right. We want him to turn left right now by 90 degrees because then he'd be pointing that way. Ready to draw that new line? That's exactly what we need here. So let's do that. Let me go to that page. There's turtle dot left and turtle dot right. LT for short, RT for short. But yeah, you can say turtle dot left and then give an angle in degrees. So like turn turtle left by 45 degrees. Turn left by 90 degrees. That's what we want. So turn left 90 degrees. It's just turtle dot left 90. And if I rerun this by typing F5, look at him, he's facing upward now. And now if we have him go forward in his current direction another 100 units, he'll end up where we need him to be. Forward. There we go. Yeah. So that's the metaphor, that's the library. Are there any questions about any of the things that I've done so far? I've drawn half a square. You can imagine how cool this will get once you learn how to draw fancier things. So yeah, now he's here. If he kept going forward, he would go off the page. We don't want that. We want him to turn again left, right? We want him to turn left 90 degrees. One more time. Because then we could draw this line, go forward another 100 units, so then we'd be at 0, 100. And then we want him to turn, because he's facing this way, turn left again, 90 degrees, and make the last line. So it's a repeated process that eventually we'll learn how to use loops for. But it's just going to be a bunch of left turns by 90 degrees and go forward. That's how you draw a square, at least starting in the bottom left corner. So again, turtle dot left, 90 degrees. Now he's ready to draw the next line. Go forward 100, please. Forward 100. Run it again. We just need to turn left by 90 one more time and go forward by 100 one more time. Then we're good. Then we've got ourselves a square. Yay! That's beautiful. Any questions about that? Circle's fancy. There's a turtle dot circle function if you want to look at the documentation for that. It makes it in a very weird way, but you can try it, that's for sure. Definitely play around. But yeah, as you're debugging all this, like, oh no, it's not working, the turtle might be moving a little too slow for you, so there's a turtle dot speed to speed him up. Get to where you were much quicker. So you can go turtle dot speed, and you can set it to either a string or a number, because why not? So you can be like turtle dot speed fast, turtle dot speed fastest, which is apparently 10 and 0. I don't know. I forget what the default is. I guess normal is 6. Fast is 10. Alright, so turtle dot speed fast. I don't know. You gotta do that before you draw anything, because it affects him from then onwards, right? So make the turtle go fast. Turtle dot speed fast. And then, I don't know if you remember how fast he was drawn before, but he draws it faster now. Ooh, that was a very fast square. Okay. So, let's see here. What do I want to do? All right, I want to give you time to try something. So I have a question for you now. I'm going to share my code with you somehow. I guess I'll do it on Discord. If you want to go look on Discord, maybe you're already typing it. But I'll copy and paste it into Discord, if nothing else. And then what I'd like you to do is add to the end of this code, and I want you to draw a second square some distance away while looking at the documentation, because there's going to be some issues that you might run into. You can do it, Discord. I believe in you. So again, your objective is, I drew this square for you. Maybe make the turtle go down here, draw a smaller square. I don't know. Or draw a littler square inside of the bigger square. Whatever you'd like to do. Draw a square somewhere, please, that's separate. So I'll give you a few minutes to try that. I sure hope that I copied it. I'll just copy it again just in case. Here we go. So there is the code, if you'd like to get it from there. And remember to not name your file the name of the library, because then I won't be able to find the library. So don't name your file turtle.py, please. Name it anything other than that. Some things that you'll have to worry about when you're drawing your second square are going to be, you got to tell the turtle to pick his tail up, otherwise he's going to keep drawing a line. So you can say turtle.up to pick the tail up and don't draw anything, then you can move him somewhere. Turtle.down has the turtle put his tail back down, and then if you move him from then on, he'll start drawing things. And then finally, turtle.setHeading you might find useful. I think the default, when we first started drawing the square, the turtle was facing to the right, and that was something that is not true at the end of the first square, right? He was facing downwards. That's a different direction. So if you wanted to get him back facing to the right without like making him go forward or anything, you could always use turtle.left if you want to, but turtle.setHeading with a certain degrees always just makes him go facing a certain degree. So to the right is 0 degrees, so you say turtle.setHeading 0 to make him face to the right. That's 0 degrees. Then this is 90 degrees, facing up. Then facing west is, you give turtle.setHeading 180. And then facing down is turtle.setHeading 270. Okay? So, yeah, maybe setHeading is going to be useful to you, and then turtle.up and down definitely will be useful. So please try. Take a few minutes to draw a second square, and then I'll help you if you have any issues. And then we'll draw even more complicated things. Oh, yeah. You did. I think you made a file called turtle.py accidentally. That has made it not be able to find the real turtle. So you have to go to this weird looking place in the computer, delete this file. So go to the file browser and try and get there somehow. So you have the C drive, so I guess. Oh, that one. That's perfect. Just click that and go delete. Or I don't know where you can do that. Maybe highlight it. Try. Oh, no, delete, not the backspace. So press back. mind if I try using my notes? Try this. Then can we delete it now? So yeah, because of that same name. Back down. Go somewhere new. Take another minute or so. And then I'll do it for you as well. All right. So let me do it too. Just realized that the operating system on these computers is Windows 11. I have not used Windows 11 yet. I'm glad I didn't update. It looks horrible. Okay, so let me, I don't know, let's draw this tiny one. Let me pick this one to draw. So the turtle's already facing downwards right now in my program. So we need to get him facing right again. So I can make him turn left by 90 if I want to, or I can be like turtle.set heading. Let's draw a second square. Turtle.set heading 0 means face east. Face east. And then I can make him go like turtle.forward, I don't know, 150 or something. And then he's going to be in the right spot to draw the next square. But we've got that silly little line right there. That's not useful. We don't like that line. So what you got to do is you got to pick his tail up. Turtle.up. Pick your tail up. And then move. Now he's over here. And then I can start drawing my new square. But again, I need to put his tail back down to do that. He won't make marks until his tail is back down again. But now he's in the right spot to draw. Put your tail down. Okay, and now I can draw a tiny little square that is just a combination of forward, left, right? Forward by some smaller amount to draw a smaller square, right? Still left by 90. Let's draw a 25 by 25 square. So forward by that one, that one, that one, that one. I guess I technically don't need that last. Go left. Yay! Alright, so that's my square. Did we get anything similar to that? Maybe we did fancier things, but do you understand how I did that? Are there any questions about it? Very, very fun little programs you can make in the Turtle library. I'm a big fan. It's great for teaching how to program. All right. So if we're still good with that, let's up the difficulty. Let's draw an equilateral triangle. So you remember what equilateral triangles are all about? Every side is the same, right? I cannot hope to draw this in the correct way, but every side is the same. And so let's say we start right here at 0, 0. We can totally make the turtle go right and draw this, like that would be fine. Maybe we'll make these size 200 or something. So these will all be sides that are length 200. Because in an equilateral triangle, right, all the angles are the same. Boop, boop, boop. And all the side lengths are the same. Boop, boop, boop. So they'll all be 200. What's the angle? They're all the same angle. What angle is it to make an equilateral triangle? Do you remember? Yeah, it's 60. If they're all the same and we know it has to add up to 180, 180 over 3 is 60. So these are all 60 degrees. Every single one of them. So that'll be fun. So that is what we had to plan. And now I think we can do it. Make a new file. I'll copy most of this stuff because I'm going to need import turtle. I'll do all that boilerplate stuff at the start. And I'll call this triangle.py. Let's get rid of most of these things, but a lot of them I can keep. There. That's good enough. So turtle.forward 100. And then you'd think, right, that it would be turtle.left or something, 60 degrees, right? And then go forward by 200 again. So let's try that. Oh, I'm sorry, it's 200, not 100 for this example. 200 units. But that's not what we wanted. That's like on its way to draw a pentagon or something. I'm not sure. But that was not enough left turning. What was the problem there? Why did that not work? So let's draw it out. So the turtle wanted to go this way, right, if we kept him going forward. So really, in order to eventually face this way, we need him to turn not by 60 degrees, turn left by not by 60 degrees, but by 180 minus 60 degrees. Do you remember our geometry? This angle, the opposite one along the line, is 180 degrees minus 60 degrees. That's 120. But even if you don't remember that, Python can do the math for you, 180 minus 60. That's how much we needed. There we go. And then we can have him turn left again by that same amount, and then go forward by 200. And that will make an equilateral triangle of size 200. Okay? Any questions about that? That was a trickier angle calculation, wasn't it? Does that make enough sense? But yeah, you can do this for any regular polygon now. You can make a hexagon. If you remember how many degrees is every thing in a hexagon, every side. What's the angle between them all? Do whatever you like. So yeah, we did 2 of them though. We did triangles and squares. So I have one last example that will be the hardest. And this will be very similar to a programming assignment that I will give you. So I will draw my initials. All right, my initials are LN. So let's do that. L is going to be super easy, but N is going to be horrible. So let's figure this out. So let's plan it first of all. Here's what I want to draw. L, then N. Let's make it look something like this. Let's make every letter the same kind of like boxiness, so it's that size and that size all over again kind of thing. And let's pretend, here are some good numbers that I came up with last semester. Let's pretend that this is 125 width and then 200 height for the L. Okay, so that implies that this is also going to be 125. And this will also be 200. And then we have to worry about, okay, how far apart do we want these letters? Because there needs to be some space there. Let's say we want a little bit. So like 40. I don't know. Definitely not to scale. But let's at least do the L right now. All right. So let's start this. I don't know where to start this, honestly. We need to move the turtle over a little bit, don't we? So let's play around with this. I'll call this initials. Initials.py. And so if I were to start moving, I'd be in the middle. So I kind of want the turtle to go to the left a little bit. So like, I don't know, turtle.set heading 180. Like, let's get the turtle over to the left side of the screen. So I'm going to set his heading to make him face west. And I'll make him go forward a little bit there. I'll actually get rid of the speed. I'm doing what's called commenting out this line. This is a very common thing to do in computer science. I have made this turtle.speed fast line not execute anymore. I've turned it into a comment, so it's not actually going to get run. I'm what's called commenting it out so that it doesn't make the turtle fast. So I want to see something first. And I accidentally edited the wrong file. There. Back to normal, I hope. Let's go to the initials.py. That's where I want it to be, sorry. So set heading 180, so face west. And I wanted to comment out the fastness because I wanted to watch this happen. So if I face him west, that's fine. So go over, please. Let's go like 200 that way. He's going to draw stuff right now. Let's pick up his tail too. Well, let's get him in a good spot to draw the L. Let's move him up a little bit. So turn right. Right 90. And then turtle dot forward 100. I'm not sure. So now he's up there. That's a good place to start, I think. I'd like him to start there. So when I move him, I do not want him to make marks right now. This is just me getting the turtle into position to actually draw what I want to draw. So I'm going to, before I do any of this, turtle.up. Okay? And now he's in the right spot, so I'll just say turtle.down. So let's see here. Get the turtle into position to actually start drawing stuff. And now we're ready. Now we are ready to draw. But if I wanted to draw the L in the normal way, starting up top here, he needs to start facing downwards. So I'll say set heading again, turtle.set heading, and I'll give him 270. I'm going to make him face down, face south. .270, so face south. And this is draw the L. Next, we need to draw the N. That will be much harder. So face south, and so I think we're pretty much there. He's ready to go. So we want to move him forward by 200, and then we'll turn him. All right, now it's all from the turtle's perspective. We want him to start making the other line of the L. Is that a left turn or a right turn to get into position? So he's facing, I don't know, this way. I want him to turn left. He would want to go that way. We want him to turn left, please, by 90 degrees. Turtle.left. If only I could spell turtle. And then, in theory, he's in the right place. Yeah, now he can go forward by 125. That was our number that we came up with. Turtle.forward 125, and I have an L. Yay. That was fun. So, that was the easy one. Now, we need the space in between the letters. So the turtle's already facing the way I need him to go. I want him to go forward by, what was it, 40? So go forward by 40, but don't make any marks. I need the space between the letters. Space between letters. So he needs to go forward by, we said 40, but I don't want him to make marks because right now he's going to just make a very long L. No. So we got to pick him up. Turtle that up. And then back where he's ready, back where he goes, where he ends up, we need to put him back down. There we go. So he picked himself up for a little bit, went forward 40, and then he's put himself back down so that he's ready to draw the N. And let's draw it like we draw an N with our pens. So he's starting here. Let's face him upwards, and we can at least make that line. So that'll be, I don't know, a left turn by 90, or I could use that heading, whichever one you want. So turtle dot left 90. Turtle dot forward by 200, right? Because that's the length of the side, or the height of every character. That's what we picked. And so that's all well and good. And now the question is, what in the world is that angle? What in the world is this angle right here? How? Because he's facing this way. So we want him to like move by 180 minus that question mark, right? We need to figure out this angle right here. Okay? That is not going to be the most fun thing in the world. So the answer is, how do I determine that angle? Import the math library. Because what is this but a right triangle? Oh man. Boop. So I can use, which is it? I need this angle. I know the opposite and the adjacent. What do I have to use then in order to determine the angle? Do you remember our SOHCAHTOA? Very good. Yeah, it's tangent. So the tangent of question mark, whatever that is opposite over adjacent. So 125 over 200. You thought you never needed geometry ever again. Sorry. You need it now. So in order to determine question mark then, we need to take the inverse tangent. Oh goody. So question mark equals inverse tangent of 125 over 200. That will give me that angle that I need. Lovely. So we need the math library. Python math. I need the inverse tangent. Where's that? It's called atan. It's called the arctangent. That's another name for it. So atan, and then we give the thing. Okay? So, I don't know. I'll call it angle in the program. Angle equals math. I need to import math, by the way. Import math. Usually do it all up top, even though I only need it down here. Math.atan, inverse tangent of 125 over 200. So that will give me the angle in the angle variable. Give me my question mark. Yay. But not so fast. The turtle is controlled using degrees. These math functions give back an answer in radians. So we're not done. This question mark is not yet complete. This is in radians. We need to convert it to degrees. Okay? There's a function for that. Angular conversion. So we say math.degrees, and then we give something in radians, and it will convert that thing from radians to degrees. Okay? Gosh, that was fun. So math.degrees of math.atan 125 over 200. Does it make sense, this line? What I needed? I needed this angle, but I got that angle in radians, so I need to convert whatever that gave me to degrees with math.degrees. And now in the angle variable, I hold exactly the degrees of that turn in the n. All right, so now I have it. And I can turn by that. But not by that, right? I don't turn by that. I turn right, because he's facing this way. I need him to turn to the right by that angle minus, or 180 minus that angle. I need to turn by this much, not by the angle itself. Okay? Same issue that we had with the triangle. So, we're ready finally. Turtle dot right by 180 minus angle. All that work just to set him up in the right way. Yay. Okay. Now, I have to make the turtle go forward. Now he's facing in the right direction. I now need to know how long this is. Oh no. How do we do that? I need this length L here. What is L? But again, this is a right triangle. I know both sides of it. L is the hypotenuse, so I can use the Pythagorean theorem. Wow, we need that too. So this is going to be L squared is equal to 125 squared plus 200 squared. Solve for L. Take the square root, right? Boop. You know how to do that. I asked you to do that last time. So let's save that. L. Let me give you some room down here. L is equal to, well, we need 125 squared plus 200 squared. I can get that. 25 star 2 plus 200 squared star 2. Then I want the square root of that. So math dot square root. And that's how far I want to go forward right now. Turtle dot forward by L. Oh yeah. And then I'm almost home free. I need him, because he's facing this way, I need him to turn again this way, which is going to end up being, I believe, we want to turn left by 180 minus question mark one more time. Not right anymore, but left. Let's see if that was correct. Oh yeah, and then we'll go forward, finally. We're facing upward again, by 200. And that, my friends, is my initials. Yay. Any questions about anything I just did? That was a bit complicated, wasn't it? So, I don't want to do this. I think this is fine. The last thing that I want to say is you don't ever have to do this trig stuff if you don't really want to. Look up turtle.goto in the documentation. Turtle.goto is going to save your life here. I encourage you to play around with this stuff, though. It's very fun. Turtle.goto is the same as turtle.setPos or setPosition. You just give XY coordinates of where you want the turtle to warp to, and he'll just move there regardless of his current direction. Okay? So I can say right now, like the turtle's facing upwards right now, I can just be like, hey, turtle, I don't care which way you're facing, just turtle.goto 0, 0, and watch. Whee! He'll make a mark, he'll go straight there and just doesn't matter, he'll just like drift that way. So that'll be useful for you one day. But I've showed you the hard way. That was worth learning. Okay. Any other questions about this example? Does it make enough sense what needs to happen in order to draw stuff? Okay, so in the remaining time, I have so many things to talk to you about because we have the midterm on Wednesday. I can't like release some things now, some things then. Gotta do it all right now. So I have 4 things to talk to you about. Good thing we didn't take the whole time. Let's go through each of them. So this is a essay and programming assignment due week. So let me give you another. These will be due week 10. So essay for you is just a short one, 500 words. I would like you to read an article. So this article, hopefully it's still, the link isn't dead yet. Cool. So read this article, please, about a very infamous piece of technology called the F22. Please read about that. And I'd like you to write a response to it. So here's the response that I want. Please talk about any false assumptions that were made by the companies involved. You may want to consult the Wikipedia page if you'd like about the incident. You will learn a lot about it by reading this article. And please tell me what you would have done differently to prevent the disaster. So I want you to have your critical thinking cap on, of course, but that is those are your prompt. That is your prompt. Those are your directions. And just write an essay of 500 words about this. You don't have to cite anything, but you can cite the article if you want to, if that would help with your word count or other sources, if you'd like. But yeah, just read the article. Talk to me about false assumptions. Tell me what you would have done differently to prevent this horrible, horrible thing that happened with this machine. We'll talk about eventually in class. Okay? That's a 500-word essay. Shouldn't be too bad. It's just not too fun to learn about, I guess. So sorry I'm making you read a kind of sad article. But it's important. Important to not repeat this issue ever again. Any questions about this? So that's assignment 1, due week 10. Next assignment, this is your first Python programming assignment. So what I'd like you to do in Python is I would like you to draw your initials, so kind of like what I was doing today in class, and then also somewhere else, maybe right after them, please also write your graduation year, the year that you intend to graduate, either from here, from a 4-year college, whatever your plans may involve. So please write a Python program that uses the Turtle library to draw your initials and then also the year that you intend to graduate. So for me, it would have been LN20, because that was the year that I graduated, 2020. But maybe for you, it's 26, 23, 24, 22, I don't know. So that is what I want. All right. So in addition to your initials, also draw the last 2 digits of the year that you're going to graduate in. And if you'd like, you don't have to do the fancy angle stuff. You can just use GoTo. But that's a good start. Remember to add your digits. Okay. So that is going to be your next programming assignment. That'll be a 2-week one as well. Okay. Any questions about that? So I want to see your initials and then your graduation year. That's the program that you'll be making. So again, make a video, explain it to me. It doesn't have to be long. And for you, people who have already programmed before, I do want you to learn Python. So if you already programmed before, I want you to get on to this assignment track now. So please do the regular assignments from now on, for those of you who have programmed before. I'd like you, though, to go above and beyond these basic requirements because you can do fancier things. So maybe learn how to use loops a little bit ahead of time. Do some cool stuff with randomness, maybe. So, yeah. But this is the assignment that I want you to do from now on. Do the normal one. The one up top. Okay? Any questions about that? So everybody's doing Python stuff from now on. Okay? So that's a 2-week assignment. Programming assignment 5. Let's see here. Third thing. This is not an assignment per se. But it's something that I'd like you to do if you have the time and are interested. You have already evaluated me in class, right, for the school, and I don't get to read those reviews, obviously, until I've submitted grades, right? So I don't get to hear what you've said. But maybe there's something that I should hear. So I have made a little Google form that I encourage you to fill out. Please fill it out with as much or as little as you would like to. I would really appreciate it. It would help me improve the class for this semester as well as for future semesters. So please fill out these little questions that I've made for you. This is called the mid-semester feedback form because we're in week 8. That's pretty much the middle of the semester. There's 16 weeks of normal classes and then 1 week of finals. So we've almost made it to the technical middle of class. So pat yourself on the back for that. But yeah, please fill this out if you're interested. I would appreciate it. It would help me improve the class. Okay? Any questions about that? I'm obviously not going to grade you on this. I don't even see that you've submitted anything. Completely anonymous. All right, so that's that one. And then finally, I also want to give our first extra credit opportunity of the class, because with a midterm I like to get, or with an exam I like to give an extra credit opportunity usually. So here is an assignment that is worth up to 5% extra credit on top of your final grade. I'll give you like a month to do it, so October 28th-ish will be your due date, depending on your, I don't know, assignment group or something. But yeah, this will be worth up to 5% extra credit. And here's what I want. I want you to learn a brand new language. If you've already learned JavaScript, you can do this one too. It'll be cool stuff. But you can also talk to me and I can give you something of equal difficulty if you'd like to learn a different language. But go to this Khan Academy course about doing cool turtle-like stuff in JavaScript, which is a different language, a very popular one, and go through all these little things. Okay? So if you would like just half of the extra credit, just 2.5%, please complete every lesson, project, challenge thing up to and including the variables section. So that would be, not this page, but scroll, variables. So you'll prove to me by turning in like a screenshot or a video that you've completed all of these little things. So this one, oh gosh, I can't highlight it. That's lovely. So like all these little things, like these little icons will change when you've completed them. They'll be colored or something. Just show me that they're all colored up to and including the variables section, and that'll be your submission. Okay, so if you want the 2.5, do that. If you want the full 5% extra credit, go up to and including the interactive program section. So I think it'll be really fun because you'll learn about animations. That's something we haven't even done yet in Turtle Land. So up to and including interactive programs. So do all these, make sure everything, these plus signs, these stars are all colorful, indicating that you've completed them to 100%. And yeah, just upload a video as proof, showing me that you've completed all those sections. Okay? So I hope that's fun. Just me forcing you to learn some cool stuff, and that will really help with your Python programming and your Scratch programming too. Okay? And your computational thinking, because that's part of this class, I would say. So that is my extra credit opportunity for you, due in about a month, up to 5%. Any questions about that one? All right. That is, I think, every single thing that I wanted to remember to talk to you about. So remember, midterm's going to be in class on Wednesday. You're going to come here. You're going to click this, click here to take the exam, and it will be like, all right, there will be a start button. It will appear. It's not going to appear until 4 p.m., the time that class starts. You get 75 minutes once you click start. There should be a timer. If you don't see the timer counting down in Canvas, yell at me the second you start the exam. So I want to make sure you know when the time is going to run out, because it won't let you type anymore when the timer runs out. So the due date is not really 5:30. It's 75 minutes after you started the exam. 5:30 at the very latest if you got here 15 minutes late or something. Okay, so keep your eye on the timer or on the clock if you got here extra late or something. But you're just going to take it on Canvas. Okay, I hope that makes enough sense. So yeah, that is, I think, everything that I wanted to talk about. So I can at least stop recording.